I am Dr. Chittaranjan Mondal, Basic Science of Humanities Department, Swami Vivekananda Institute of Science and Technology. In this video, I am going to discuss the application of Regula Falsi method or false position method to find the root of a nonlinear equation. We discuss with an example. Find the positive root of the equation x e to the power x minus 3 equals to 0. Correct up to 4 significant figures using false position method. So, to apply the false position method, first we have to check some 2 points where the root actually lies. In this case, we need positive equation, positive root. So, we first consider f of 1. So, corresponding f of 1, so e minus 3, that is negative value. This gives negative value. And f of 2 gives the positive value. So in this case, we claim that between 1 and 2 there must exist a positive root. If we draw a graph, the graph may be like this. I am not going to draw the exact graph, but maybe like this. Suppose this is 1 corresponding, let me draw now. This is 1, suppose this is 2. This is f of 1, this is f of 2. So f of 1 is negative, f of 2 is positive, and the given function is continuous function. That means obviously the given function cut the x-axis at some point. That point actually the root. So this is the root. X equals to suppose alpha. We have to find this root in this case using the false position method or Regula Falsi method. So f of 1 and f of 2 negative. So we consider x1 x0 equals to 1 and x1 equals to 2. And the false position iterative method is xn plus 1 equals to xn minus 1 by f of xn minus 1 into f of xn, where n 1, 2, 3, 4 up to. And now we draw a table. So this is the n number of iteration n, xn minus 1, suffix n minus 1, for f of xn minus 1 is negative, xn for f of xn is positive, and the value of f of xn minus 1, values of f of xn, and using this iterative formula we calculate f of x of n plus 1 and corresponding the functional values. Here we consider x0 equals to 1. Okay, not x0. One, 2. So x0 equals to 1 and x1 equals to 2, corresponding the functional values f of x0, corresponding the functional values of f of x1 and x1 using this formula and the corresponding the functional value. If we calculate likewise using this formula in the sixth iterative place, we get 1.048 and the previous value, previous xn minus 1, 1.048, and the given question is find the root up to 4 significant figures. So here 4 significant figures, 1, 2, 3, 4, and here also 1, 2, 3, 4. So matched up to 4 significant figures. So therefore our root is 1.048 and the last one 9, so 1.049. This is our root of the given equation. Thank you.